the hum of unseen machinery, a rhythmic pulse echoing through vast, silent halls. For centuries, humanity has been captivated by a material born not of metal or stone, but of a tiny, unassuming creature. We touch it, wear it, adorn our homes with it, yet few truly understand the intricate journey from a delicate, shimmering cocoon to the luxurious fabric that graces our lives. This is not merely a story of production, it is an ancient saga, a testament to nature's ingenuity and human perseverance, a secret whispered across millennia. Imagine stepping through a hidden portal, leaving behind the familiar world to enter a realm where art and science intertwine, where the most delicate threads are spun into strength, and where the mundane transforms into the magnificent. This is the world of silk, a universe cloaked in mystery and wonder, a material so revered it once fueled empires and ignited global trade routes. Its very essence speaks of elegance, of a touch that is both ethereal and enduring. But what lies beneath that smooth, cool surface? What unseen forces are at play in its creation? Today, we peel back the layers of time and technology to reveal the hidden world behind one of the planet's most coveted textiles. We journey deep into the heart of a factory where the ancient craft meets modern precision, where the delicate dance of silkworms and the intricate choreography of machines converge. Prepare to uncover the secrets of a material that has dressed royalty, inspired poets, and continues to define luxury. This is the untold story of silk, from the humble cocoon to the high-end fabric, a journey that promises to unravel the very threads of our understanding. The allure of silk is undeniable, a fabric synonymous with luxury, comfort, and timeless elegance. But its journey from a tiny silkworm cocoon to a shimmering garment is far more fascinating and complex than most imagine. For over 5,000 years, silk has captivated civilizations, originating in ancient China where its production was a closely guarded secret, punishable by death if revealed. Legend has it that Empress Leizu, wife of the Yellow Emperor, discovered silk when a silkworm cocoon fell into her tea, unraveling a lustrous thread. This serendipitous moment marked the beginning of an industry that would shape history, creating the legendary Silk Road and connecting distant cultures through trade and innovation. What makes silk so extraordinary? Beyond its exquisite feel, silk boasts an incredible combination of properties. It is one of the strongest natural fibers, with a tensile strength comparable to steel, yet it remains incredibly lightweight and soft. This paradoxical strength and delicacy are due to its unique protein structure, primarily fibroin, which is secreted by the silkworm. This natural protein fiber is also hypoallergenic, making it ideal for sensitive skin, and its smooth surface resists dust mites and mold. Furthermore, silk is a natural temperature regulator, keeping you cool in summer and warm in winter, a testament to its remarkable breathability and insulating properties. It can absorb up to 30% of its weight in moisture without feeling damp, making it comfortable in various climates. Its natural elasticity allows it to drape beautifully and resist wrinkling, making it a favorite for high-fashion garments and luxurious home furnishings. The sheer volume of work involved in producing silk is staggering. To create just 1 pound of raw silk, approximately 3,000 silkworms are needed, consuming about 100 pounds of mulberry leaves. These tiny creatures, the larvae of the Bombyx mori moth, are voracious eaters, growing rapidly over a few weeks before they begin their intricate cocoon spinning process. Each silkworm can spin a single, continuous thread up to 1,000 to 3,000 feet long, sometimes even longer, to form its cocoon. Imagine the delicate precision required to harvest these threads without breaking them, a task that has been refined over millennia. The quality of the mulberry leaves directly impacts the health of the silkworms and, consequently, the fineness and strength of the silk fiber. Farmers meticulously cultivate these trees, ensuring they are free from pesticides and diseases, a testament to the foundational importance of agriculture in this high-tech industry. Historically, silk production was an intensely manual process, requiring countless hours of labor. The cultivation of mulberry trees, the careful rearing of silkworms, the meticulous reeling of silk from cocoons, and the subsequent weaving were all performed by hand. Entire villages and families dedicated their lives to sericulture, passing down knowledge and techniques through generations. Today, while much of the artistry remains, Modern technology has revolutionized many aspects, allowing for greater efficiency and consistency. However, the fundamental principles of sericulture, the raising of silkworms for silk production, have remained remarkably consistent, a testament to the effectiveness of ancient methods. The transition from manual labor to automated processes has been gradual, preserving the core essence of the craft while enhancing output and reducing physical strain. One of the most surprising facts about silk is its versatility beyond textiles. Silk is increasingly being explored for biomedical applications due to its biocompatibility, biodegradability, and mechanical strength. Researchers are developing silk-based implants, sutures, drug delivery systems, and even scaffolds for tissue engineering. Its unique properties make it an ideal material for interacting with the human body, showcasing a future for silk far beyond fashion. This ancient fiber is proving to be a cutting-edge material for 21st century science, with ongoing research exploring its potential in optics, electronics, and even as a sustainable alternative to plastics. The protein structure of silk can be manipulated at a molecular level, opening doors to a myriad of advanced materials. The lustrous sheen of silk, often referred to as its scintillation, is not due to a dye or coating but to the triangular, prism-like structure of the silk fiber itself. This unique cross-section allows silk to refract incoming light at different angles, producing a natural shimmer that changes with the light, giving it a depth and richness unmatched by synthetic fibers. This optical property is a natural marvel, a subtle dance of light that enhances its visual appeal. Furthermore, the smoothness of the fiber surface contributes to its soft hand and prevents it from trapping dirt or allergens, adding to its hygienic qualities. This inherent beauty and functionality are what makes silk truly unique. Consider the environmental impact. While the production of synthetic fibers like polyester relies heavily on fossil fuels and chemical processes, silk is a natural, renewable resource. The Bombyx mori silkworm feeds exclusively on mulberry leaves, a tree that requires minimal pesticides and water once established. The byproducts of silk production, such as pupae, can be used as animal feed, and wastewater from processing can often be treated and reused. This makes silk a more sustainable choice, especially when compared to its petroleum-based counterparts, highlighting its ancient wisdom in a modern ecological context. Efforts are also being made to develop more eco-friendly degumming and dyeing processes, further reducing the environmental footprint of silk production. The entire life cycle, from tree to fabric, demonstrates a remarkable harmony with nature. The journey of silk is also one of global economic significance. Countries like China, India, Uzbekistan, and Thailand are major producers, supporting millions of livelihoods. The demand for silk continues to grow, driven by its luxurious appeal and increasing awareness of natural, sustainable materials. From haute couture runways to everyday luxury items, silk maintains its prestigious position, a testament to its enduring quality and the intricate process behind its creation. The global silk market is a multi-billion-dollar industry, constantly evolving with new fashion trends and technological advancements, yet always rooted in its ancient origins. The engineering challenges in silk production are subtle but profound. Maintaining the perfect environmental conditions for silkworms, temperature, humidity, and a constant supply of fresh mulberry leaves is crucial for healthy cocoon development. Any deviation can impact the quality and length of the silk thread. Furthermore, the delicate process of reeling the silk from the cocoons requires immense precision to avoid breaking the continuous filament, which would significantly reduce its value. This balance between natural biology and industrial precision is a constant, delicate dance. Modern factories employ sophisticated climate control systems and automated reeling machines that mimic the dexterity of human hands, ensuring optimal conditions and minimal waste. Did you know that not all silk is created equal? While Bombyx mori silk, or mulberry silk, is the most common and prized variety, there are also wild silks produced by other types of silkworms, such as tussa, era, and muga silk. These wild silks often have a coarser texture, a more irregular appearance, and natural colors ranging from cream to coppery brown, reflecting the different diets and environments of their respective silkworms. Each type offers a unique aesthetic and feel, expanding the rich tapestry of silk's possibilities. Tussar silk, for instance, is known for its strength and slightly rougher texture, often used in home furnishings, while Muga silk from Assam, India, is famous for its natural golden sheen and durability. These variations highlight the diverse beauty of nature's silk producers. The history of silk is also intertwined with espionage and cultural exchange. For centuries, China maintained a monopoly on silk production. The secret eventually spread to Korea and Japan, and later, famously, to the Byzantine Empire in the 6th century, when 2 monks reportedly smuggled silkworm eggs out of China in hollowed-out bamboo canes. This act of industrial espionage allowed the West to begin its own silk production, forever changing global trade and the course of fashion. The story of silk is truly a global epic, woven with threads of discovery, intrigue, and enduring beauty. This historical narrative underscores the immense value placed on silk throughout history, driving both innovation and international relations. The journey of silk begins long before the factory gates, in vast plantations of mulberry trees. These trees are the sole food source for the Bombyx mori silkworm, and their healthy cultivation is paramount. Farmers meticulously tend to these groves, often employing sustainable agricultural practices to ensure a continuous supply of fresh, pesticide-free leaves. Once the silkworms hatch from their tiny eggs, which are carefully incubated under controlled conditions, they are meticulously reared in specialized environments, often in large, multi-tiered trays within climate-controlled rearing houses. For about 20 to 30 days, these larvae consume enormous quantities of mulberry leaves, growing rapidly through several molts, shedding their skin 4 times. This phase, known as sericulture, is critical, as the health and diet of the silkworms directly impact the quality and quantity of the silk they will produce. Strict hygiene and temperature regulation are maintained to prevent diseases that could decimate an entire batch of silkworms. When the silkworms reach maturity, typically after their 4th molt, they stop eating and begin to seek a place to spin their cocoons. They are often transferred to cocoonage frames or trays, where they can attach themselves and begin their intricate work. They excrete a liquid protein, fibroin, through 2 salivary glands, which solidifies upon contact with air, forming 2 filaments. These filaments are held together by sericin, a gummy protein. The silkworm meticulously weaves these threads around itself in a figure-8 pattern, creating a protective oval cocoon over several days, usually 3 to 8 days. This natural engineering feat results in a single, continuous filament that can be hundreds of meters long. Once the cocoons are fully formed and the silkworms have completed their transformation into pupae, they are harvested. To prevent the moth from emerging and breaking the continuous silk filament, which would significantly reduce its length and value, the cocoons undergo a process called stifling. Traditionally, this was done by sun-drying, but modern factories use more efficient and controlled methods such as steam, hot air, or baking in specialized ovens to kill the pupae inside while preserving the integrity of the silk. This step is crucial for obtaining the long, unbroken threads required for high-quality fabric and is performed with precision to avoid damaging the delicate fibers. The next stage is degumming and reeling. The harvested cocoons are first softened in hot water, often with a mild alkaline solution, to loosen the sericin that binds the silk filaments together. This softening process, known as cooking, allows the individual filaments to be carefully unwound without breaking. Skilled operators, often aided by automated machinery equipped with optical sensors, gently brush the cocoons to find the end of the silk filament. Several filaments from multiple cocoons, typically 5 to 10, depending on the desired thickness, are then combined and twisted together to form a single, stronger raw silk thread, known as a strand or bave. This combined thread is then reeled onto bobbins or swift reels. The sericin, which still coats the reeled silk, provides some protection during subsequent processing, acting as a natural lubricant and binder. After reeling, the raw silk threads are often subjected to a process called throwing. This involves twisting multiple raw silk strands together to create stronger, more uniform yarns with specific characteristics. Depending on the desired fabric, different types of thrown silk can be produced: singles, untwisted raw silk, used for sheer fabrics. Tram, 2 or more raw silk strands lightly twisted together, used for weft, providing fullness. Or organzine, 2 or more raw silk strands twisted tightly in one direction, then 2 or more of these twisted strands twisted together in the opposite direction, used for warp, providing strength and elasticity. This twisting adds strength, elasticity, and texture to the yarn, preparing it for the rigors of weaving. The final degumming process, where the remaining sericin is removed, can happen at various stages. If it hasn't been fully removed during reeling, it's done now, typically by boiling the silk in a solution of soap and water. This process makes the silk softer, shinier, and more receptive to dyes, but it also reduces its weight by 20 to 30%, as sericin accounts for a significant portion of the cocoon's mass. The removed sericin can sometimes be collected and used in cosmetics, pharmaceuticals, or even as a natural adhesive, demonstrating a commitment to minimizing waste. Once the silk yarn is prepared, it moves to the weaving or knitting stage. Modern factories utilize high-speed looms, often computer-controlled and equipped with advanced sensors, to weave the silk into various fabrics like satin, charmeuse, chiffon, organza, or taffeta. The choice of weave structure dictates the fabric's texture, drape, and appearance. Robotics and advanced automation ensure precision and efficiency, handling the delicate silk threads without damage, maintaining consistent tension, and preventing snags. Quality control checks are performed throughout this stage, often using optical scanning systems to monitor tension, identify flaws, and ensure consistency in the fabric's construction. Dyeing is another critical step. Silk's protein structure allows it to absorb dyes beautifully, resulting in vibrant and lasting colors with excellent color fastness. The dyeing can occur at different stages, as raw fiber, top dyeing, as yarn, skein dyeing, which produces richer colors, or as woven fabric, piece dyeing, which is more economical for large batches. Modern dyeing facilities use precise temperature and chemical controls, often with environmentally friendly dyes and processes, to achieve desired shades and ensure uniform penetration. After dyeing, the fabric undergoes finishing processes, which might include washing, stretching, tentering, drying, and calendering, passing through heated rollers to impart smoothness, luster, and specific textures. These finishing treatments enhance the fabric's aesthetic and functional properties. Throughout the entire manufacturing sequence, rigorous quality control measures are in place. From inspecting mulberry leaves for pests to monitoring silkworm health and cocoon quality, from checking the uniformity of reeled threads to scrutinizing woven fabric for defects like slubs, broken threads, or uneven dyeing, every step is carefully managed. Automated optical scanners can detect minute imperfections, and highly trained human inspectors provide a final, discerning eye, ensuring that only the highest quality silk reaches the market. Safety protocols are also paramount, ensuring a secure working environment for all personnel involved in handling machinery and chemicals, adhering to international industrial safety standards. Finally, the finished silk fabric is prepared for logistics. It is carefully inspected one last time, measured, cut, and packaged, often rolled onto bolts or folded into precise dimensions, protected by plastic wrapping to prevent damage during transit. Automated conveyor systems transport the packaged fabric to storage areas, where inventory is managed by sophisticated warehouse management systems, ready for distribution to designers, garment manufacturers, and retailers worldwide. The journey from a tiny silkworm egg to a bolt of luxurious fabric is a marvel of biological engineering and industrial precision, a testament to the enduring appeal of this ancient, yet ever-modern, material. From the ancient legends of Empress Lezu to the high-tech looms of today, the story of silk is a continuous thread of innovation, luxury, and sheer natural wonder. We've journeyed through the meticulous care of silkworms, witnessed the delicate art of reeling, and explored the advanced processes that transform a humble cocoon into a fabric that has draped royalty and defined elegance for millennia. The intricate dance of biology and engineering, the blend of tradition and automation, reveals a world far more complex and captivating than we could have imagined. The sheer dedication and scientific precision required at every stage, from cultivating mulberry trees to the final finishing touches, underscore why silk remains one of the most prized materials on Earth. But the world of manufacturing is vast and full of equally astonishing transformations. If the journey of silk has left you mesmerized by the hidden processes behind everyday luxury, then you'll be thrilled by what's next. We've seen how nature's delicate threads are refined into opulence. Now, imagine a journey from rough, unyielding rock to the purest, most coveted metal on the planet. How do we extract and purify a substance so rare and valuable it has shaped economies and fueled desires for millennia? Don't miss our next deep dive into the fascinating world of material refinement. Click on the video that just appeared on your screen. Gold Refining Factory from rock to pure 24K gold bars to uncover the secrets of another incredible transformation. Make sure to subscribe to our channel for more exclusive looks inside the factories that build our world, and hit the notification bell so you never miss an episode. And tell us in the comments below, what was the most surprising fact you learned about silk today? Was it the strength of the fiber, the sheer number of silkworms needed, or its unexpected uses in medicine? We love hearing your thoughts.